Testing, thank you. You guys are hilarious. Spanning tree? Spanning tree. What are you all doing here? Bunch of network geeks. We're going back to the 80s. We're talking about spanning tree. All right. My name is Patrick Gargano. It's my last session. Thanks for coming out. Hopefully we have a bit of fun. You probably know spanning tree, so we're just going to go through this really, really quickly. No, I'm just kidding. What I want to do is do a couple of slides of review. Right, I've got 30 minutes. I don't have time to teach you all the ins and outs of spanning tree. So literally, I've got 2-3 slides to just kind of refresh your memory about how it works, some of the terminology, and they're going to go right into a topology, and we're going to try to break the loop. Initially, I'd wanted to do it with Slido. If I'd had maybe more time, I would have done it with Slido. So instead of Slido, we'll just do it like this. We'll just interact like this without our face in our phones instead. So here we go. All right. I'm French-Canadian. So I brought a kilo of maple syrup candy with me from Canada. I'm not allowed to go back to the country with any of it. So I must give it all out now. So if you have the correct answers to some of my questions this morning, you get a little kick of sugar to go with it. I also brought a copy, I think it's the last one that I've got. Yeah, so the copy of my book, which is an Encore exam prep book. Just saw one of my attendees from Tuesday. I ran a 4-hour lab. He went to do Encore this morning and he passed it, so that's super exciting. So I'll give this out at the end of the session as well. I don't want to just do a random draw for this. I'd really like it to go with someone who's getting ready to take Encore soon-ish, next couple of months, right? So maybe we'll, at the end of the session, I'll ask whoever's doing that to maybe come to the side. We'll do like a small draw for the book off to the side, right? Here we go. What's the point of spanning tree? What's the point of, sorry? Okay, here we go. Any other definite? What's the point of spanning tree? What are you trying to do? Okay, yes. Anyone else? What's the point of spanning? You know spanning tree. You're just here because you want to confirm your knowledge. I know that. You're not here to learn something new. You're like, I know my spanning tree. This guy's not going to teach me anything new. Check this out. What's the point of spanning tree? The answer is on the slide. Thank you. There we go. These are not trick questions, right? You won't get kicked out of the session. 2 topics, like I said, a couple of slides of review. I'm going to do that quickly because you should know this. And then I want to jump into the challenge. So this is the point of spanning tree. We're going to have some redundancy. So you're going to take some cables and you're going to click and build some extra physical redundancy in your switched infrastructure. Unfortunately, that's going to create a layer 2 loop. And then the frames are going to do this forever. So spanning tree, invented by, let's go folks, invented by, I also gave you one though. Right? Yes, Radia Perlman, right? Yes, you knew too, here you go. Radia Perlman, 1982-ish? Anyway, something like that. So the whole point of this is to do this, right? This is what we want to do. So by the end of the example that we're going to build out quickly, I should see a lot of X's in my topology. We want to break not just one loop, we want to break all the loops, right, to create a loop-free topology. And how are we going to do that? Step 1, what's the first step in spanning tree? The first thing we need to do, those that got a candy, you got to be quiet now. So, first step of spanning tree. Come on, first step of, sorry? There we go. First step, grab a candy. First step is electing the root bridge. Listen, I'm going to use a bunch of different words to define. I'm going to say it's the heart of the network, right? It's where everything has to flow through. It's the boss, whatever. So we need to elect the root bridge. Step 2, root port. Did you get one already? Yeah. You got a candy already. Step 2 of spanning tree. Come on. Step 2, root ports. All the other switches, notice what I just said, right? The non-root switches, all the other switches have to figure out the best, fastest way to get back to the root. Does that make sense for everyone? We're going to call those root ports. So it could be this one over here. It could be this one over here. Step number 3. What's the answer? Tell someone. Step 3. Designated port. Step 3. Here, just for fun, I'll give you one. I'm too quiet. We're going to elect the designated ports. The designated ports are actually the ones that are going to stay on, right? They're going to actually forward traffic. And then whatever's left over, this is going to happen. Okay? All right. What's the magic behind all that? It's this thing right here. What's this thing called? The answer's on the screen. That's a BPDU. Okay. Listen, the BPDU is fairly complex. I'm just going to focus on these 4 fields here. Those are the ones we're going to use the most in this whole challenge slash kind of mini lab we're going to do. We got the root bridge ID. So this has the information about who I think the root is, right? There's a bunch of switches. One of them is the root bridge. This is going to be the ID of that device. How much does it cost me to get to this boss? Who am I? And what's the port I'm using to get there? Fairly straightforward. The bridge ID, if we go like OG, like 1982 spanning tree, really simple. It's got a bridge priority and a MAC address. We know that the default value is 32,768. Cisco comes around, they're like, yeah, but we would like to do a flavor of spanning tree called per VLAN spanning tree. So Radia, I'm sorry, your bridge ID thing isn't quite, we need to tweak it. We're going to include the VLAN ID in the bridge ID, but we're still going to use the MAC address to build all that out. Okay, making sense? If you've got an argument to make it now. No, you're good? All right. I like to call this, like the root bridge is the heart. Every 2 seconds, we're going to hit a heartbeat, and that BPDU is going to flood the network, right? It's going to go everywhere. Last review slide. We're going to use this a lot. So as we go through the decision, thank you for coming. Here's a candy. Fantastic. We're going to use these 5 steps to figure ourselves out, right? To figure out how spanning tree is going to resolve and break those loops. Those are the steps we're going to use. Notice the key word here. For some reason, that's what she decided. She decided we're going to go low instead of go big. So we're going to go low. It's always the lowest value of whatever that's going to win. And we're going to use this to break the tie, okay? You're going to notice every once in a while as we go through this process, there's going to be a tie. 2 switches are going to be fighting it out about a segment, about a situation. Something needs to be resolved, but there's going to be a tie. So we're going to use this to break that tie when that happens. And finally, the last thing, and maybe probably the most important that you need to keep in mind for this next few slides is we're going to talk about something called the cost, right? At the end of the day, we need to figure out how much it costs us to get back to the root bridge. The lower the value means that the faster it is. So I've got the short values, and if you don't mind, we'll use those for the example, just because this is a bit much to run in your head. You haven't had lunch yet. You're kind of running low on energy. I haven't gotten candy to the folks in the back, so sorry about that. So we'll use the smaller numbers, and I'll be honest with you, my topology is pretty straightforward. It's a lot of fast Ethernet and gigabit, so a lot of 19s and 4s. Okay, so focus on that. In case you're interested in changing your whole cost calculation for your spanning tree at work, feel free. I'm not to be held responsible. Here's the command. You can flip it to long and have some more interesting values. Okay, are we ready? Let's kick it off. Here's our topology. The other reason I didn't want to use the Slido is because I want to ask you guys questions, but you need the topology to answer the question. If I put the Slido poll, then you don't have the topology. It didn't make any sense. So here we go. So this is our topology. 5 switches. We've got a lot of loops, so we need to sort that out. Notice there's a lot of fast Ethernet links, quite a few gigabit ports. I was nice. I didn't muck about with the bridge priority ID value, so I left it at 32,768 everywhere. But you can see the different MAC addresses I'm using. And this is our baseline. So we're going to turn that network on. And I can see everyone's like, okay, this is it. All right, okay, get you. So here we go. Step 1, you guys told me that the first thing we need to do is figure out who the boss of the network is going to be. The root bridge, we're going to use the bridge ID to figure it out. High or low? High or low? Thank you. So I've just told you this value is the same everywhere, so you should be focusing on the MAC address. I'm going to give you 5, 4, 3, 2. That's my Slido poll. Do you like that? It kind of counts down. 1, 0. Okay, raise your hand. Is it switch 1? Is it switch 2? Switch 3? Switch 4? Switch 5? Come on, come on, come on, come on, come on. Yes, it's switch 5. Right? They all have the same priority value, but this guy's got the lowest MAC address. when I'm looking at the MAC address, am I looking at it like this or like this? Like this, thank you. So we're looking at it from here, left to right, and switch 5, which, like this is my core switch, my aggregation switches, my access switch. This switch is in the closet in the basement of the oldest building in the company, and it is now the boss. Well done. All right, we're done with step 1. That's the boss. Everything is going to flow through this switch. So far, so good. All right, what are we doing? Nice. Okay. Step 2. Now we start getting interesting. All the other switches. And the terminology we should use is a weird terminology, non-root switch. I just like to call it the other switches. All the other switches now need to figure out what is the fastest, best way to get back to the boss. And how are we going to do that? It's thanks to the BPDU. We know it's going out every 2 seconds. And this is kind of interesting. Because this guy is the boss, the BPDU being sent out every 2 seconds is going to have a root path cost of what? Because and it costs how much to get back to itself? Thank you. So I didn't want to go crazy here and have 10 slides with this thing kind of moving all over the place, but I just wanted to kind of start it off. So it's going to take off, and those BPDUs are going to start flowing this way up into here. What I really want to focus on, though, is that for the next step, to elect the root ports, it's all about the root path cost. And what we're going to figure out very quickly is some simple math. It's a cumulative value, right? A cumulative value. What I mean by that is the BPDU is going to come in here, right? It's taking off with a value of 0, right? Because it's the boss. It's going to come in on a fast Ethernet port. So this is some heavy math. We haven't had lunch, I know, but I'm trying my best with the candy. 0 plus 19 is 19. The root path cost out of this port to get to the boss is 19. Pretty straightforward. It's the same thing here. It's going to cost 19 to get to the boss. 19, 19. And this is going to happen throughout the entire topology, right? So what's the end result when this happens? So I've showed you a bit of the math. I'll point a few out, okay? So here we go. Let's just pick some ports, and I'll show you, and you'll quickly figure this out. Let's imagine this port right here. What's the fastest way for it to get back to the boss? Well, I could go this way, right, which is a fast Ethernet link, so 19, and then come down one of these two and hit the boss. 19 plus 19, 38. How about this one? I'm going to do like a big old curve here, right? So I'm going to go out of this gig port, out of this gig port, come down this fast port, 27. So it's not complicated math. It's just a little bit of cumulative values. Obviously, you've got a complex topology, quite a large spanning network, a large LAN network. You'll have quite a lot of values here. So again, let's look at this one. Coming down this way, maybe turning the corner here. So 4 plus 19, right, 23. Is this making sense? Are these values okay with everyone? If I'm coming down this way, same thing again, right? 4 for the gig port, 19s. I promised you, I'm just focusing on these two right here, 4s and 19s. Okay? All right, so let's clean it up a little bit. I got rid of the math, and I'm just showing you now the final values. And again, don't freak out. These are just a bit of math, right? 4 plus 19, or 4 plus 19, or 4 plus 4 plus 19. Those are these values in red. And I added little arrows to basically just remind you what that value basically means. That this switch, for example, if it goes out of this port, it costs 27 to get to the root bridge. So now that we have those values, we're actually ready to start asking the question, maybe answer the question, which port on these 4 switches are going to be the root ports? Let's start with the easy ones, and then we'll go to the more complicated ones. Let's start with this guy over here. It could go this way, I could go this way, I could go this way, or I could go all the way around. Guess who's going to win? The one with the lowest root path cost. So that's going to be our root port. Everyone still with me with that one? Again, if you have an argument, see me after. We'll have a beer. We can talk it up. How about this one over here? This is another easy one. We've got 3 ways, right? I could go this way. I could go maybe like that. Or I could go like this. Cost here is 23, 19. again, right? Don't forget what Radia said. It's always the lowest value that's going to win. So we're going to hit the root bridge this way. Okay. Those are the easy ones. There's that root port. Let's go at the top. We've got a problem. We have a tie. I promised you that if we do have a tie, we need a tie break mechanism. And the tie break mechanism is going to use those 5 steps that I mentioned earlier. So what do I mean by a tie? If the switch goes this way, it's 23. If the switch goes this way, it's also 23. So we need to break this tie. We can't have a tie. So we're gonna go through these steps here. The next one to break the tie is the lowest sender bridge ID. The sender bridge ID is the bridge ID of the device that sent the BPDU. So this switch is going to get 2 BPDUs, and it's going to compare them. It's going to say, okay, what's going on? And what's the value that it's going to look at? It's going to look at the bridge ID. It's going to look at this, and it's going to compare it to this. Which way are we going? Are we going gig 1 or gig 2? Who says gig 1? Thank you very much. Who says gig 2? See me later. Okay, gig 1. Excellent. So lowest sender bridge ID. Oh, yes, there we go. Our root port is there. We're good? Next one is this one. Another complicated one. This one always catches people out. There's a question on the CCNA exam on this, I'm sure. There's a question about this on the Encore exam, I'm sure. It's in my book. It's in all the books. This is a classic one that always catches out people. We have a tie again. Switch 2 has 2 ports it could use to get to the root bridge with the same root path cost of 19. We need to break the tie. We need to go through the tie break process. So the next step is, which port received a BPDU with the lowest sender bridge ID? Well, the BPDUs came from the same switch. So is everyone in agreement that it has, again, the same value? We have a tie again. Step number 4 is a bit of a funny one. It's asking to compare something called the port priority. Now, this is a value that you as network administrators can actually configure. You can change it. By default, it's 128. I haven't changed the default values in my example here. So let's just assume we still have all the default values that are running through the topology. So we still have a tie, is what, the bottom line is we still have a tie at step 4. We need to go to step 5, and this is where it all falls apart. No, this is where people sometimes make a mistake because they're like, okay, I read in the book that Patrick told me I should get, and it said I have to use the lowest port ID, and guess where they're going to look? Guess where they're going to look? They're going to look here, and they're going to get the wrong answer. Because it's not the local port that's important here. It's what? Look, it says it right here. It's the sender port. So I did do this I did it on purpose. I don't know if you noticed what I did here. 1 is connected to 2. Yeah, you would never do this in real life, right? In real life, you would always, right? Anyways, 2 is connected to 1. I did that on purpose. So we're not looking at these ports, we're looking at these ports because the BPDU is being sent by this guy. So who's going to win? FA02 or FA01? 2. Congratulations, ladies and gentlemen. We finished step number 2. I think the switches do this a bit more quickly than we're doing it right now, but we're having a great time. I think we're ready for step number 3. Step number 3, I just want to define it very quickly. So we talked a little bit about it at the beginning. We called it a designated port. I said, this is the port that's going to stay on. I said, it's going to forward and receive packets. What I want you to keep in mind as a trick, if you like, in your head is that every segment needs a designated port. What I mean by a segment is a line in my diagram. Every line will have a designated port. No choice. How are we going to figure that one out? Guess what? I know I'm very repetitive. We're going to use the root path cost. Now, I'm pointing out something. I tweaked the diagram a little bit. If I just go back for a second, right? These were like massive values, right? Because that was the cumulative value that port had. What I did in the next slide, because we're at step number 3, is I just kind of wiped that, and I just put the individual root path costs of the switch that it's using to get to the boss, right? So, for example, out of this port, it's 19, for example, right? So it's sending that value in the BPDU, right? That's the value that's being sent to its neighbors. And what's going to happen on each end of that segment, there's going to be a fight. Who's going to be the designated and who's Well, who's not going to be the designated, right? And like I said, it's all going to be about the route path cost. So we can maybe start with the easiest one in the bunch. Is this switch important? Is all traffic flowing through this switch? Should we turn off some of its ports? So how about it? Yeah, right. So how about if we leave them all on? How about if we call them all then designated? But surely it can't just be because I'm telling you so. There must be some math, and there is a bit of math. Who's going to win here? 0 or 19? 0 or 19? 0 or not, right? Lowest value always wins. That's the math. That's the math that's happening right there with the BPDUs. 0 and 19. So guess what? This is the easiest one. If ever you get a question, a spanning tree question like this to work out, don't even think, I mean, you can think about it, but don't even think about it. Just go designated port, designated port, designated port, designated port. Like, boom, done. It's the boss. We need to leave the traffic to be able to flow through that switch. No choice. So that was the easy one. How about the next few? Let's have a look at this one over here. So how about if we look at this? Yeah, let's look at this link first, right here. That'll be an easy one to do. Got two BPDUs. One BPDU is saying, hey, I've got a route path cost of 19. This one's saying, hey, I've got a route path cost of 23. I guess you win. You should be the designated port. Now, logically, I know what you're going to say. Well, Patrick, of course it has to be designated. Why? Why would you say, of course, Patrick, it has to be designated? Because what? Because at the other side is probably the most, not probably, this is the most important port on that switch. Are you going to turn this thing off here? Wouldn't make much sense. So we definitely need to keep this one on. That's going to go designated. Again, it's just math. 19 is less than 23. But between you and me, logically, this makes a lot of sense. Let's go over here. Let's do, I'm trying to think which one we're going to do maybe over here. This is another easy one. Got 19 again and 23. So guess what? The math says this one should be designated. So that's an easy one to do. We can sort that one out. And now we're going to get a little bit more interesting. I mean, it's not super complicated, but just a little bit more interesting. We've got a tie. These guys are fighting it out on this segment. One of them has to win and be the designated port. I'm going to give you a few seconds to have a think about it. Which one? Is it going to be SW2 gig 2 or SW4 gig 2? Who should be in charge of that segment? Who's going to be the designated port? All right. What do you think? SW2, SW4, SW2. SW4. Those that said SW2, see me after for some remedial spanning tree lessons. It's over here. Why? 32,768, 32,768, still a tie. We go from left to right. 0, 0, 0, B. Oh, that's an F. I know it's a little hard to see. It's hard for me to see, but that was an F, and we've got a B over here, so this one wins. It's lower. Okay? How are we doing for time? Okay, good, good. Next one that we should do, let's do this segment over here now. We have to do them all. Notice that I'm a bit random here. I'm just doing them in whatever order I feel like, because you can. It's okay. All right, I started with the easy ones, right? I started with this one, and then I did the easy ones where there wasn't a tie, and I kept the complicated ones for the end. So let's take this segment over here. I'm going to give you a few seconds to think about. Hopefully you've noticed we have a tie again, 19-19. So I'm going to give you a few seconds. It's my automated Slido poll, live, technology-free, no AI involved. SW3, who think it's SW3? No. SW4? Thank you. Very good. No extra lessons for you then. We're doing really well here. Anything else left? I think we've got one over here as well. We also have a tie. I'll give you a few seconds to think about it. There you go. You have candy for you. SW2, SW3, SW2, SW3, SW2. Let's have a look here. 000BF. Oh, okay. D139. Tricky. Not really. It's like we're almost done. You can have my candy. No, I don't want extra candy. No. I'll take a beer later. I think we're almost done. Anything left to do? Not really. Well, kind of. We need to then turn off all the other ones. Everything else that's left over has to be blocked. We have to stop the packets from flowing. Again, I'm not talking about rapid spanning tree here. I'm just talking about old school 1982 Radia Perlman flavor spanning tree. We're gonna block those ports. She would have called it a non-designated port, right? So that's why I wrote NDP here, non-designated port. On a Cisco switch, you might see it marked down as alternate instead. At the end of the day, I just want this to happen. So that's why I put a bunch of big X's. I know it looks a bit crazy with all the X's, but I just want you to realize how many links or segments are not being used anymore. How many do we have to start off with? 1, 2, 3, 4, 5, 6, and 9 segments. And there's a bunch that aren't doing anything anymore. They're backups. All right. If we had another half hour, and this is what I do when I teach this at a college or with a learning partner, I would do this over like a little bit more than half an hour. I would then start doing things like turning off a switch and asking the students to work out what happens, or disconnecting a cable and asking students to work out what happens, or changing a priority somewhere. That's all you need to do. And then you blow people's minds. Oh no, what happened? The network is freaking out. So no more traffic here. No more traffic on this bottom link. No more traffic here. None here, none here. So just to clean it up a little bit, those are the only links, the only segments where traffic is now flowing. Ladies and gentlemen, spanning tree 101. I still got lots of candy. Listen, we've got just a few minutes left. I'll ask whoever wants to maybe thinking of taking the encore exam to stick around, hang out, and we'll do a little draw on the side for those of you that are planning on doing the exam. Andy mentioned something. So I'm going to go do an exam at about 2:30. I'm going to do ENSLD. There's still room. You guys know you have a free exam while you're here? Who took an exam this week? Please, who took an exam? Oh, man. That's it. Guys, there's still loads of availability. It's free. You walk up, you go through those doors, you sit down, you take out 2 pieces of ID, and you say, I want to do 50% off. Sorry, it was free before. It's 50% off. Thanks, Andy. 50% off. Just walk through the door. Nothing to lose. Just go do an exam. CCNA, Encore, whichever one, data center, service provider, security, whatever you feel like. Just walk through the door and go sit it before you leave today. Anyways, thank you for coming to my talk. Like I said, let's have a little huddle over here for those interested in maybe getting a copy of my book, right? Cheers. Thank you, everyone.